Good evening, all of you. Can you hear me?
Yes, can.
All right, okay. Uh, right, so we'll continue from where we were on that day. We discussed about workbook, basically, and we discussed and we learned about how to include quantities from the measured quantity, right? Or in other words, we have dimensions in one side, right? We have dimensions, we have created dimensions according to the, let's say, according to the item that we want to measure. And then we have created a workbook, which is basically Excel-like working space. And we learned about three levels, basically, right? Level 1, level 2, level 3. Level 1 is the summary, level 2 is the BOQ, and level 3 is basically the measurement part. Right, so how we can drag and drop the measurements into workbook. So we learned not all, but we learned some portion of that. Okay, so today we'll continue from there. Let me open CostX, okay, and share the screen as well. You can open your CostX. Right, so default project, and then the building name was Muscat Hotel, so you open this. Right, now you can see a workbook also in addition to our drawing. So we have uploaded only one drawing for now, right? And then we carried out all the measurements on that particular drawing. I hope you can remember this. Yeah, this is what we have measured. If you want to see everything together, you can say reset view. We have to be on the drawings, and then you can say show all. And then you can see all the hidden lines, everything, because when we measured certain items like area of the columns, area of the PCC and so on, so we removed unnecessary lines so that it will be easier for us to take measurements, especially when we use a shift key to measure the area, right? If it is a close object, you can get the area in no time, right? You don't have to go to what you call line mode or point mode. So that's what we discussed. And then let's go to workbook now, right? You have the workbook, and we have created a workbook called BOQ Hotel, right? You don't have to double click, because when you just click on that, you will see the workbook here. And if you want to go to the next layer, we all know we were in the substructure, and we have to go to substored. Right, not quantity column, not any other column. I'll show you all the other columns later, but for now, it is the subtotal column. You double click on that, and you go to the BOQ, that particular section. Right, you don't have to have any formatting here. Right, you can delete this empty line if you want. Right, we'll come back to formatting later on when we talk about what you call reports. Right, so this is what we have been doing the other day. So we measured blinding. You go to dimension view, and then if you expand this one, right, concrete, and this is what we have measured. So we have measured PCC, and then we have measured columns, concrete, and then footing concrete, and then tie beam. So those are the 4-5 items that we have measured. Now we use those 4-5 items to generate other quantities. So that is the beauty of this. Okay. And then if you want to go to the next level, you double click on this, and you see the link. You can see when you click on this, You can see because we drag and dropped this one, and then you can see a link has been already created. So you are not going to do that. That link will be created automatically. Right. Whenever you do some changes here, right, this will be automatically updated. So the BOQ will be automatically updated. If you have a rate, let's say for certain rates you have put in, and then summary page will be updated automatically. So that is how it is. So it is visually linked, unlike in AutoCAD or any other measurement, because unless you do kind of physical linking through Excel, right? Normally it doesn't link, but this one, when you drag and drop, a link has been already created with this. So that is very important for you to understand, right? So we did the foundation, tie beams, and columns, right? Everyone was on that on par with that. Now we will continue other stuff, right? I will show you ramps and staircases as we proceed. It's the same thing. If you want to measure something, let's say ramp, you have to create a dimension group called ramps, and then measure on the plan or on the elevation, you have to measure the length by giving the thickness. You have to define the thickness. Guys, can you check your microphones when someone is just double check? I get a background music. Sorry, background sound. All okay? Yeah. I turn off the video. Okay. Right. So now today we will look at how to calculate the excavation and the formwork. Formwork also we have calculated based on the calculations, based on the dimension groups. We have calculated the formwork. We all know something called wall area, right? So when we drag and drop, right, we selected the wall area. So when you select the wall area, because we have measured the foundation as area. If you can remember, foundation we measured as an area. If you want to go to this, and if you see, click on this, sorry, foundation. Yeah, you can see foundation we measured in area. When you measure area, right, and the wall area would be the girth or the perimeter into height. Height, of course, you need to define. It gives you the perimeter into height. That is called the wall area. But if you measure a linear meter, something, let's say masonry work, later on we'll learn. When you measure linear meter, and the wall area would be, of course, the wall area of the masonry work or block work. Right? In other words, if you measure a line, wall area means length into height, actual wall area. But when you measure an area like footings, your wall area would be perimeter into thickness of the footing, which is basically the formwork area here. Right? So that we have used that one to calculate the formwork. Right. You can remember this. So these are the wall areas when you drag and drop. You just take that one, right? It will ask you what you want basically. You don't have to select volume. You select wall area, correct? And that's how you get. Right. Just a second. Right. So it's a matter of, selecting what you want, right? For the purpose of quantification or for the purpose of, I mean, you can retrieve uh, the parameters that you have captured while you are measuring the concrete. So you use those parameters, other parameters, right? When you calculate formwork quantity or maybe bituminous quantity or maybe earthwork quantities. Now we are going to see that now, just now, right? So these are the formwork that we have measured. I think everyone was very clear about that. Now we'll continue with, let's say, um, we will measure now excavation. Okay. So I have started with this. So I am going to insert certain lines here as excavation. Or, yeah, I think that's the best way because this goes as substructure, right? The whole thing related to substructure can be on this. So you can create some blank line and then you can copy your BOQ, excavation BOQ here, right? So I'm going to do that now. Go to the BOQ, right? Uh, let's say site preparation. I'm not going to do all these things, okay? I'll take an example. Let's take, right, you can't copy and paste, so you need to create some lines here to get the space. You can use the shortcut also. You can see, right? You can use insert rows, control INS, right? So you can use that as well. Otherwise, just insert. Right. Let's see that's enough for the moment. And you copy this without quantities. Okay. Right. So you just copy and put it here. Right. Control V, Control C, just to copy. And if you want, you can remove these empty lines. You don't need collection pages. I'll show you why later on. Yeah. So the quantity is this, and then you can copy this down to unit column. Control X, Control V. Like Excel, you just copy and paste or cut and paste. Right. So you don't worry about the numbering. I will tell you later why. Right. So we have copied this down to our Excel sheet, sorry, workbook, and you can remove all this, what do you call, blank line if you want. Right. Can you do that? Can you copy your BOQ to workbook? Right. So we'll do the formatting later. Right. So we are going to, I'm going to show you, okay, topsoil removal, everything is possible because it's very easy. You have to demarcate a line and you have to create, in that case, you have to create Because since you have not measured the entire area, you can create a dimension group called topsoil removal 300 millimeter, and then you can measure. The problem is you don't have a line here. You can see you don't have a line here for the for the demarcation, right? So what you need is basically you have to draw a line for the topsoil removal, or this is a foundation. You can go for a site plan, right? Not this one. This is foundation layout. You go to site plan and then mark. You know the extent of the work, so you can measure that extent of the work as area, and you can define thickness as 300 millimeter, and then you get the area, right? So that's it. That is how. So I'm not going to do that because it's pretty easy, and I have showed you how to measure the area. You have to apply that area now. Right. Now I'm going to measure the pit excavation and the trench excavation. Trench excavation for tie beams and the pit excavation for footings, basically. Right. So that is what I'm going to measure now. Right. How do you do that now? Now just go to this one now. You can see here. Let's say existing ground level here. Existing ground level is about 1.2. Okay. Top of the beam is about 1.5. This level, ground floor level. Right. Your original ground, existing ground level is, let's say, minimum depth, excavation depth is about 1.2. So let us quickly work out uh, the footings, the excavation for the footings, or we can call it as pit excavation, right? If you have combined footing, it can be a mass excavation, but in this case, you have isolated footings, and then you can say it is pit excavation, right? How do you find out pit excavation? Normally, how do you do it manually? That is the PCC area or PCC length and width into the height, correct? Suppose height is 1.2 from the natural ground level or existing ground level, right? That is what I have marked from the dotted line. You can see the red dotted line. So that is your excavation, right? This red dotted line is the excavation for each footing. And who will declare that? Who will decide that? The PCC area will decide the excavation, extent of the excavation. Therefore, we can use the PCC area into the height. So you can get the pit excavation in this case. So how do you apply in CostX now? Right, let's go to workbook now. And what you need is basically this excavation pit for foundation. Right, I'm not going to do this topsoil average. If you have a site plan, what you can do is you can measure the area, and then you can create a dimension group called topsoil removal, and you can measure this as area, or if you want, you can measure this as a cubic meter itself. When you defined uh, the dimension group, you can say the thickness is 300. You can do that. Now I'm going to do the pit excavation. So what you do is basically you go to subtotal, sorry, quantity now, because we are in the level 2 now. You are in the level 2, you go to quantity column and double click, and that is your measurement level. So what you do, right? You know PCC, entire PCC in the project. You know entire PCC in the project. You can see here, the outer line. That is your PCC area. Inner line is the edge of the foundation. We all know that. You can see from here. Inner line is this line or this line, and that is the edge of the foundation. Outer line is the PCC line, edge of the PCC. So when you do the excavation, you have to do the excavation up to the edge of the PCC. And also you don't have to keep any working space or anything, because excavation quantities are to be measured net. That is a measurement rule. Almost all the international measurement rules says the quantity has to be net. That means no working allowances and all. if you have to have working allowances, that has to be built into the rates, right? So that is part of the quantity surveying. But for now, I take uh, the depth as 1.2, okay? Because this is 1.5. So you can always find out from the drawing the depth from natural ground level or existing ground level to the bottom of the PCC. Suppose it is 1.2, right? So what we need to do is, right, you go to workbook now, and we have measured the PCC, but what we need is area. Don't worry, because we have already measured the area. So what you do is you can drag and drop here. And instead of selecting volume, now you see, you can, not the wall area. It's not the wall area now. Wall area is the girth into the height. Okay. That is the envelope basically. And here you have to take the area of the PCC. Area of the PCC. Right. It is 483. You can see and say update. But that is only the area. That is the area of all the PCCs. But there's another dimension that is missing. If let's say if it is only 5 cubic square meters, then 5 square meters into 1.2, isn't it? Because let's say this F1 or F2 is only 5 square meters of PCC, right? Or 6, let's say 3 into 2, 6 square meters of PCC area. And that area into the height is your excavation, isn't it? The red, the dotted line in red, you can see here. The dotted line in red is your excavation for this particular footing. But since we are taking all the footings at once, you don't have to measure footings separately. We can take all the footings as once. Then we can take all the footings area here in this way. Then what is the height? Height is 1.2. Height is 1.2. Don't think that it will give you automatically, because this is 2D drawings, okay? Nothing is automatic other than the calculation and the linkage. Everything everything else is manual, because we need to feed in the information. We are doing 2D measurements. So I have taken the depth as 1.2. So normally in the drawing, it will give you minimum depth of the excavation is 1.2 or 1.5 or maybe 2 meter from the natural ground level. So whatever the data that has been given, you need to apply here. Now in this case, I am using 1.2 from the existing ground level to the bottom of the PC. Right. So I have used 1.2 and I get a value, and that is in my BOQ. You can see 581 cubic meters. But do you think this is, yeah, pit excavation is fine, right? Pit excavation is fine because it is all the foundations here, right? All the foundation. The area you need to dig is basically the area of the PCC and then 1.2 meter depth, right? And then there are another types of foundation here, which is the trench excavation, right? So that also possible. Before I move into that, can you get this value for the PCC? Sorry, for the excavation, pit excavation, can you get 581 cubic meters? And let me know if you get a value when you get the value. Right? How do you get this? This is how your measurement sheet. Again, what I do is I have the PCC area here. I know that. Yes, I have taken 48 cubic meters because I wanted the volume when I measured. Now what I want is the area. So when you drag and drop, right, you can select not the volume, but not also the wall area, but area, right? That is the plan area. So you select the area and you will get it. You will get this way. But we know the depth of the foundation from this diagram. It's 1.2 from the natural ground level. Therefore, I apply 1.2. And you get 580 cubic meters of pit excavation. Now you can change the description, right? You can say pit excavation. You can change the description. Right, everyone is getting 581 in the BOQ, rounded up. Please drop a message. Okay. Are you getting 581? 57, 578. There's a small error in your PCC quantities. That's why you get 578. It should be 580.3 to be precise, but rounded up to 581. You have to double check your PCC quantity. Are you getting 48 cubic meters?
Yes, sir. 48 I'm getting.
Then still your areas could be slightly different if you go to like dimensions, and then if you go to areas, probably some of the areas may be different. Go to the breakdown of this item. If you want to go to the breakdown of this 48, what you do is you keep this one and go to dimensions, right? And then you can expand it. Can we double check? It has to be 6.6.29, 1.56, 1.37, 0.78, 1.37, and so on. And finally ending up with 8.8. There could have been some error in the areas of the breakdown. That is why you get a slightly different figure.
Yes, sir. Maybe I will check that, sir.
Just double check, okay?
Thank you.
Right, so everyone is, yeah, quantity worksheet, how to change decimal, I will explain you, don't worry. That is part of the lecture, okay? Set up the decimals here. It is easy, pretty easy here, actually. If you want to go to this, and then you can change it here. From here, you can see. You can do that. Or otherwise, you can assign to the entire sheet. I will show you how. Okay. You can change here. Normally you can go to the second decimal, sorry, because that is normally your measurement. And then when you go to 580, right, you can change even here, right? You can see here, you can change it. Right now, if you go to the next level, 581, that is also possible for me. Decimal. But I will show you how to set the decimal here, whether you need in decimals or you need in like round numbers. Right? Give me a second. I mean, I will explain you that. Right. As far as workbook is concerned, right, there's a default setting. So you can stick to the default setting at the moment, but individually you can change the decimal figures, right? And you can see there's a kind of a function here already. So when you double click on that, you can see this is 580.32, but it is rounded up to 581. That should be the case normally, right? Because if you refer to the principle of measurement, of measurement, it says quantity should be to the nearest whole number. If the quantities are more than 10, right? So you need to know the measurement rules. Anyway, you can change the decimals locally by clicking like in Excel, right? Here also same, you can do that, but then there's a link between this one and the measurement sheet, right? I will show you that as well later. Right. Now, let us go to trench excavation. Let us go to, that is for the tie beams. That is for the tie beams. You can see here, there are tie beams and then there will be trench excavation. Again, if I go to this diagram, you can see trench excavation. This orange color section is the trench, right? This is an elevation or maybe a section. And this is your beam. And beam is sitting like this between two footings. And then you have to dig a trench. You have to excavate a trench, which is reflected in blue dotted line. You can see here. The blue dotted line here, this line, right? That is your excavation for the tie beam. Now you can see there's a duplication because this red line is for the excavation for fit. This blue line is for excavation for trench. And there's a slight overlap. And we will do that adjustment also. So let us take the tie beam. How the tie beam will work? You can see here. Tie beam is 0.3 into 0.5. Right? 0.5 is the height. 0.3 is the width. Right? From this drawing, we know that. Right? 0.3 and 0.6. And then we know the length of the tie beam. We know the length of the tie beam, total length. So let us get the trench excavation, including this overlap first, and then do the adjustment for overlapping. Right, first, let's go to this now, and we are going to do tie beam. Right, so what we need to do is we need to double click, and now we can go to length method. Right, we can go to length method, and we know the length of the tie beam. Otherwise, we know the area. We can give the height. That is also possible. We know the plinth beam area because we have not considered any PCC underneath the plinth beam or tie beam. Okay. So in this case, you can say you can take the length of the tie beam by just drag and dropping here and select the length now. Length. Say okay. Fine. So how do you get the volume? It has to be length. Width has to be 0.3, isn't it? Width has to be 0.3. You can see from here. Now we know the length of the tie beam, or I mean total length of the tie beam we know, and we know the width of the tie beam, that is 0.3, right? So, and it is 1.2 is the depth. So that is the size of the trench. Depth is 1.2, little less than 1.1 I would say, because this 100 millimeters is not there. So depth is 1.1, not 1.2. You don't have to excavate up to this level. You can excavate up to this level and leave it. So 1.1 is the height. Total length we know of all the tie beams. And width is of course 0.3. Then you can find out the trench excavation. But we know there's an overlap. Okay, we'll come back to that. Now, right. So width, either you can type, just type the width, and height also you can type. Anyway, height you have to type. But width, I will show you one more method, right? Again, what I will do is I will drag and drop here, and then instead of volume, I select the width, because that width also given here. Now you can see when I change the width, automatically quantities will be changed. So as much as possible, you link these quantities from dimension groups to the workbook. As soon as you drag and drop, there will be a link created. You can see here. There will be a link created. Right. So whatever you change here, let's say tie beam dimension you want to change, and automatically quantities will be updated. But here height, there's no height. I mean, that you have to manually feed 1.1, and this is 1.1, not 1.2. 1.2 is up to the bottom of the pieces. So the depth is 1.1. It's like a small trench, like 0.3 width, and then it's like this 0.3 width and 1.1 height, and you get the volume. And we know the length. We know the length earlier. We have taken the entire length of the tie beam as 63.2 from this. Now, this is your quantity. You can see the quantity is here, but we know this is slightly higher because there's a duplication. There's a duplication like this. So, how much is the duplication? Duplication is this line, correct? Common area. Duplication is, one is 0.3. The length, if you take, this is 100, right? So each plinth beam, you have an overlap of 100 millimeter, both sides, right? Both sides you have 100 millimeter, width is 0.3. You can deduct that much of amount, volume, into 1.2 height. So you remove the duplication. So what I'm trying to do is I'm using this one here, and I'm going to use the I'm going to deduct the overlap. How? If you want, you can type. Otherwise, what you can do is you can drag and drop again 0.3 width, 0.3 width. I'm looking at this diagram, okay? Because this is an elevation or a section. The overlap is of course 0.3, because 0.3 is the thickness of the tie beam, other side, other dimension, and that much. And the length is 0.1 here, right? 0.1 into 0.1, both sides. So what you can do is you can take 2, and we know how many, what do you call, how many tie beams are there. You can get the count from here. You can see count. And we know how how many tie beams are there? 33 numbers of tie beams are there, but we have two sides. Since this has to be minus, so I'm going to put minus. This is 33 into two sides, okay? You have to get it correct. This is 33 numbers you have tie beams, but each one has two edges. So each edge you need to remove the duplication. So we know the edges, we know the edge of the, we know how many edges we have already calculated. 33 into two edges are there because 33 number of tie beams are there. And why I put minus? Because I want to deduct. Either you can put minus here or here. And here 0.3 is the width. 0.3 is the width. And then height is 1.2, correct? Height is 1.2. So you remove this duplication now. Height is 1.2. Anyway, 1.1, sorry. Because 1.2 is up to the bottom of the foundation. And this is only this up to the point 1.1. I hope you understood that part. That is quantity surveying and 3D visualization. And that is the adjustment I have made here. 33 number of beams I have taken from, drag and dropping here. And I have selected, instead of volume, I have selected the numbers, or the count, sorry. Then you get the number of tie beams here. So each one has 2, and that has to be deducted. Therefore, -2 I have used. And the plinth beam width is 0.3. One thing is missing. 0.3. Length is 0.1, isn't it? Length is 0.1. You can see. 0.1 is this part, okay? 0.1. Length of the tie beam is 0.1. 0.1 into 2. 0.1 into 2 into 1.1. And width is 0.3. Am I getting you? You have to visualize. 0.3 is the thickness, so 0.1. And you have 66 number of them. And the depth is 1.1. Depth is 1.1. So it has to be this much. Length is 0.1, width is 0.3, right? Height is, if you take one piece here, this one, it is 0.3, 0.1 into 0.3. 0.1 is this way, 0.3 is the other way, and the 1.1 is the height, not 1.2. And you have 33 number of them, right? You have 33 number of them. Sorry, 66 number of them. And that has to be deducted. Therefore, I put minus, or you can put minus here also. Right. So you don't have to deduct, or you have to get the sum or anything, unlike in Excel. If you go to next level, and you will know excavation for trenches is 19 cubic meter. Okay, can you get that? Can you get that? And drop me a message. And you need to understand this by looking at this diagram. Right, you need to visualize certain deductions. I'm sure you are very familiar with these deductions and so on. So you apply the same concept here, simple as that. It's not magic. So that's why I use this tie beam length method and as well as the tie beam area method, because area method is very important when you want to visualize the 3D model of the measurement. So that will be very handy. But when you measure length, you can use it for so many other measurements. Right. You should be getting 19 cubic meters. Can you drop me a message? Nineteen, good. Somebody must be arguing if it is a kind of, let's say, measured and pay contract. In most of the cases in Sri Lanka, contract type would be going as the payment mechanism would be going as measure and pay. Right, quantity can be remeasured. Then you don't have to even deduct these overlaps. You don't have to deduct these overlaps because we know the quantities are to be remeasured, and this is not a big amount. So you don't have to deduct in your day-to-day measurement. But during during the preparation of the BOQ, okay? But during the post-contract stage, of course, you need to deduct these quantities and get the actual value. In the estimation purposes or BOQ preparation purposes, you can measure to the higher side. I think it's clear, right? Now you know disposal, right? If you want to have disposal, what you do is you have to get the excavation for fit for foundation, and then you have to deduct PCC from it, right? Column foundation, right? Foundation you have to deduct, and then column, top column, right? Of course, we have measured columns up to this point, but actually what we need is from up to this point. So that is also possible. You can deduct the volume of the columns here, concrete volume of the columns, and then you get the backfilling. You get the backfilling, right? So that is how you do uh, in your measurement sheet. You don't have to measure it. You don't have to measure it. You can derive those quantities from the relationships, right? So everyone has got 19. So let us now measure. Let us now measure waterproofing. Yeah, this one. Prepare and apply 2 coats of cold applied bituminous emulsion waterproofing system surfaces of concrete. Right, anti-termite you can measure very easily if you know the plinth beam area. Right, you can just measure. You can create a dimension group called anti-termite treatment, and then you measure the area. That's all. Simple. So I'm not going to do it again because I have already taught you how to measure the area. But I will measure now. This waterproofing is little difficult, isn't it? So I'll copy this down and include in the measurements. Sorry, units. and I'll put it here. Right, I'm going to measure right. I'm going to measure prepare and apply 2 course of all applied bituminous paint. Let's assume that the bituminous paint has been applied to the entire foundation. Right, bituminous paint has been applied to the entire surface. Footings, on top of the footings and stub columns, and then here the PCC, top of the PCC, right? Only this part, okay? Only this part. Let's say we have not applied anything over here, right? So it is the top of the footings, side, and top of or edge of the PCC, and maybe side of the edge, sides of the PCC. That's all. And then beams, of course, tie beam side. There are 2 sides and top. So those are the waterproofing area. Okay, how can you derive these areas now from what we have measured already? You don't have to create. You don't have to create any waterproofing dimension group because we are not going to measure anything. Instead, what we are going to do is we are going to use some of the quantities we have already used here. Right. So let us go to this one now. How do you go to this level? Go to quantity and double click. So you can go to the measurement level or level 3 we call it, and you can see 2 arrows. That means you are 2 levels down, 3 levels down. You are in the 3rd row, in other words, 3rd level. Okay, now what is the first thing? You can say, let us break this down. Okay, so where we can apply the PCC now, you can see from here. Here on the top you can apply. Okay, on the column you can apply, right? On the column you can apply PCC up to the ground beam, ground level. Okay, up to the or on the surface of the column, and then top of the foundation, side of the foundation, side of the tie beam, top of the tie beam, and then sides of the PCC. So those are the areas, and edge of the PCC here, wherever you don't get the tie beam, right, at the edge, right, because there will be a edge between formwork and the PCC. So that also will be, for that also you will be applicable, you will be applying the bituminous paint, right? So if you break this down, you can quickly work out the waterproofing area. So let us do one by one now, right? So let us quickly, let's say for easy one, we can say sides of footings, isn't it? Right, sides of footings. And that is one waterproofing area, sides of footing. Here, sides of footing, that means perimeter into the height. So that is one area that will be painted with bituminous. You can get that area. How do you get that? You get the footings and get the wall area. Then you get the perimeter wall into thickness. Also perimeter into the thickness or the height. And that is your foam work basically, right? Foam work, it is similar to foam work area for the footing. So how do you get the foam work area? You get your footings here, F1, and drop it here. And you have to select, instead of volume, you have to select wall area. Finished. And you get that. Right. So can you can do it together, as I said before. can do it together. And not volume, you can say wall area. Right, so I'll remove this one here. Right, so that is the sides of footing. What you are measuring is bituminous paint. Okay, so we have considered the side of the footings. Sides. Right, length side and width side. Right, now we can find out the top of the footing, right? Top of the footing also we can get, but only thing is you need to deduct the column area. You need to deduct the column area. So that is possible. So let us get the top of the foundation now. Right, this is side of the foundation. Now, top of the foundation. This is for my easy reference, that's all. Otherwise, there's no necessity. Right, I just put some value, sorry, some heading so that I know what has been measured here. Top of the foundation. How do you get the top of the foundation? Area, isn't it? So you get all this one and you get not the volume, you get not wall area because we are going to get the top. That is the area, simple area. That is the plan view. And that is the top of the foundation. But you all know we cannot get the entire top area of the foundation because there's a column. You don't apply bituminous paint where we have the column. So you need to deduct the column area. You need to deduct the column area. How? You can say, this is for my reference, okay? You don't need anything otherwise. Deduct column areas. Deduct column areas. Right? How? Now you have to get the column area. You know the areas too, right? You can drag and drop the areas. Now, again, not the wall area, you get the area now. Now, how to deduct now? How to apply the deduction for this area? You apply a factor of -1. Simple. You understand? Now we have found sides of the foundation and the top of the foundation, and then we did the adjustment because when you work out the top of the foundation, we know column areas to be deducted. Right. So now how much? You get 667. But we know this is not correct because we have not taken, okay, we have taken the sides of the foundation. This is, I'm talking about bituminous paint, right? And then we have taken the top of the foundation. Now let us get the columns. Assuming this NGL, if you want, because we have measured the columns up to the ground floor level. So let us measure the bituminous also up to the ground floor level. It doesn't matter. Otherwise, we have to adjust it. Okay, so let us think that we have to get the wall area, the perimeter of the girth into height, right? So you can get the wall area or the surface area for the bitumen. So that also will get. You can apply what do you call columns. Right, columns you can drop. And what you want is wall area. We know we are getting little higher because of this height issue. We have measured the columns at different levels. Some are 0.8, some are 0.9. but that is up to the ground beam level. It's okay because natural ground level is slightly below that. So we can use the bituminous paint up to the ground floor level. There's no harm. And that is why it is. So these are the columns. What else? Right, then we have forgotten tie beams. Okay, let us finish the foundation. So we have taken the column surface. We have taken the footing surface side and the top, and then we have to take this edge. We have to take this edge other than in the intersection points. So forget about the intersection point. Let's assume this is measure and pay contract and you want to get an estimated figure. Otherwise, you have to deduct these intersections. Now, if you want to find out only the edge of this, you have to take the PCC area minus the footing area, isn't it? If you take the PCC area and if you minus the formwork area, sorry, if you minus the footing area from the top, you get this edge and the edge of the area of the edge, right? That is also possible. So let's say edge of the PCC. Again, what you got, you don't link anything from here, right? You always link your quantities to dimensions, not within the workbook, right? Edge of the PCC again. When I say edge, not this one, I'm talking about this horizontal portion, okay? That's 100 millimeter I'm talking about. You can get that area by taking the PCC area on the plan and area of the foundation, and you get this area. So let us do that. So PCC area, you get the PCC area. And we know the height 0.1. Right, so that is the edge of the PCC, this part. Then you have this side also, right? You have to paint this side of the PCC. Right, here also 0.1, here also 0.1. Now, edge of the PCC, again, you get the area girth into, this is not edge, how do you say? Here you can get the girth like wall area. This is this area, okay? Area in the sense girth into 0.1. So it is the wall area for the PCC. So it is the wall area for the PCC. If I just delete this one, when I drag this one here, it's not the volume we have to take, it is the wall area of the PCC. I have selected the PCC, okay? Say, okay. This is the wall area and you don't have to do any adjustment because it is already multiplied by 0.1. You can say edge. This edge and this edge very difficult to differentiate. Right. What else? We have taken this one right around, and we have taken this part. And there has to be some deduction because there are tie beams, two tie beams, or tie beam is in between two footings. You have to do a bit of adjustment for this area if you really want. But I'm not going to do that. And what else? We have taken sides, we have taken edge, we have taken sides, we have taken top, we have taken the sides of the collar. What else? Now, tie beams. You have to take two sides, we have tie beams and then top. Right. So, tie beams. Right now, we have to go to tie beams here. Length method, we know the total length. Correct? We know the total length of the tie beam. So, we'll take the length and we know count is 2 because two sides. So, there are two sides that you can apply the bituminous paint. Two sides. This sides, this side and this side. You know that. And then the top. So those are the three areas that bitumen paint can be applied on the thigh beam. Two sides and the top. Right. Two sides now already done. Two sides length we know. And the height is 0.5, isn't it? If you want, you can drag and drop here. You can select the height like this. Same. Right. You can use 0.5 same way as the height. And that is the two sides because length is 63 and then you have two of them and one side is 0.5 high and then the top, this is sides and then the top. Again, you can use this length right and width is 0.3, isn't it? Width is 0.3. That is the top of the tie beam. And yeah, you don't have these two because there's no two sides. That is vertical sides we have taken 2 and length is 60 but top only 63.2 length and the top is 0.3. You can see here top is 0.3, that's all. So two sides and the top, that's all, and you have pretty much covered everything now. So did you measure anything for the waterproofing? No, you have used the previous measurements to derive at a figure for waterproofing. So altogether, you should have something close to 868. Did we miss anything? And if you want, you can deduct even this intersection. Right, this intersection you can deduct because you have taken, when you take the entire footing, you have taken the entire face right around perimeter into, wall area. You have taken the full wall area, but there's an intersection here. where the bituminous will not be applied. So you can do that adjustment also if you want. 2 times the adjustment is of course you can do a adjustment here, right? You can say deduction for intersections possible. How we get count? We have 33 of them. Each one 2 sides you have, and one side is 0.3, height is 0.5. To take a section, you are going to deduct exactly the area that I have highlighted in mark 0.3 into 0.5. You have 66 number of them. You have 66 number of them. Since this is a deduction, you can introduce -2 here. Right? Now you can get this value. So you have deducted for intersection as well. So this is very accurate. So answer is 858. I want you to get it. Starting with, you have to organize yourself, right? You have to take the sides of footing first. So here you can establish the quantities, sides, and then top, and then you have edge of PCC, and then this vertical side of PCC also there, and then vertical sides of tie beams, two sides, and top of the tie beam. That's what exactly what I have done. And with that, you should be able to get the total value of bituminous paint. And it has to be right. Then move on to, you can deduct the intersection and then you can move on to top of the foundation. So likewise, can you work out all the cost? I'll give 5 minutes. I'll give 5 minutes. You can refer to your screen. I'll grab a glass of water also in between. Okay. Only adjustment I have not done is I have taken columns up to the ground, plinth beam level, not to the ground level, right? So that could be the case. That is dependent on the detailing of the drawing. So I have assumed the bituminous to be applied up to the top of the ground beam. Uh, yeah, ground beam. Right, and then we have taken edge of the PCC, and then this is the vertical edge. Let's say this is vertical edge. Right, tie beam. And this is tie beam. This is vertical edge. This is edge. Right, did I miss anything? I should be getting 858. In some drawing says you have to apply the PCC maybe on top of the PCC entirely. Then you don't have to deduct the column area. Correct? Sometimes they put the PCC on top of the, sorry, yeah, they will apply the bituminous paint on top of the PCC and on the vertical edge also, and then put the concrete footing. In that case, you don't have to deduct the footing area. I hope it's clear. That depends on the detailing of the drawing. Right? Anyone has got 858? G factor. So that is G is of course A, B, C, D, E. Those are the column heading. Factor, if you want to use factor, maybe like here too, I have used factor here too, because two sides. You can use two here also as a factor. Instead of count here, you can use as a factor also. But here when I use factor here as -1, that is the best example of how to use this factor. When you want to do a kind of a deduction, now we have taken the areas directly. So if you want to make it minus, so you multiply it by -1. That's all. So you can use this column to introduce some minus factors. So that area would be minus if you want to have a deductions. I hope it's clear. Yeah, good. Dharan has got it correct, 858. Very good. That means you have to be on the dot. You have to have very good quantity survey knowledge to get this value. It's not CostX. You are applying your quantity surveying into CostX now. Your 3D visualization and all. Because still we are learning 2D measurements, not 3D. Okay, anybody else? 858. Oh, very close. Okay, good. To sit. I know it takes time, but you have to follow certain steps. You need to be very organized. You get first sites of footings. If you have this one in your mind, you can get it. Sides of footing first. Of course, there's a deduction here, intersection point, but sides you get first, and then top you get. In that case, you have to deduct the area of the columns and then sides of the columns. You have got it for the foundation also. Sorry, for formwork. We have used that method for the foundations, formwork. So sides, top, and then again sides, and then this edge of the PCC, and then vertical edges of PCC, and then two sides of the tie beam and the top. That's all. So we have all the data. We have all the data. We have just used those data to calculate the bituminous pain. You don't have to do again any calculation. Or you don't have to measure it again. Right. Are we done? I want everyone to take calculate this bituminous paint. The quantity should be very close to 858 square meters. Right. So you can see, okay, good, Malinder got. You can see the recording again. And during the middle of the week, and then make sure that you get 858 square meters for the bituminous paint. So it goes to the BOQ like this. Right now, there are so many other items. If you know the what do you call expansion joint, you can measure the expansion joint. Anti-termite treatment you can measure from plinth beam layout, not from this. Right. So all this can be measured because you can create a dimension group, and then you can drag and drop here, or not here, I mean here. You can drag and drop to the level 3, and you get balanced quantities very easily, right, without troubling too much. Right. So I'm not going to do it. I mean, linear measurements is nothing, right? Linear measurements are nothing as long as it is shown on the drawings. Right. Now we will slowly move into superstructure. Right. So we'll come back to the substructure later. When we calculate the reinforcement, I have not told you how to do the calculation, how to calculate the reinforcement. So I'll come to that. Right. When we measure the reinforcement. So this is not 100% finish, but major quantities have been taken. We have taken the excavation today. Previous day we have taken all the concrete and the formwork. Today we have taken bituminous paint. Right? But we have not measured all of them. We have measured only concrete items. Right. Now we go back to drawings. Now we are going to measure superstructure. We are going to measure superstructure concrete. Now we need to understand one thing here. So I'll move out from workbook to again drawings. Okay. And if you see the building architecture, so we are going to measure this building. Take an elevation. Okay. This is our Muscat Hotel building, right? So we have measured the foundation, or not all, but certain elements, majority of the elements we have already measured, including excavation. Backfilling, you can do it without any trouble. If you are a good QS, obviously you can, you know the excavation quantity, and then you have to deduct the concrete quantities within the excavation, then you will get the backfilling, right? Um, so there's no measurement to be done. It's about quantity surveying, applying quantity surveying principles into the quantities. Right now, you can see here you have level 1, level 2. This is a two-story building, and sometimes, especially in Sri Lanka, measurement rule says, or measurement rule requires, standard method of measurement SLS 573 we use here. It requires your quantities to be presented in level wise. Right? Ground floor level quantities, you have to put it in a separate section of the BOQ. And then from ground floor to roof, those quantities will have to be put as a separate section of the BOQ. So in other words, the BOQ will be or should be divided level wise. Right? But for me, it doesn't say that way. All the all the quantities can be combined and presented at single quantity. Entire concrete in the project can be presented element wise, right? We all know slab, 200 millimeter thick slab, staircases, columns, right? You can segregate all of them. But in certain cases, you can't, because you have to give the quantities level wise, especially in Sri Lanka. Right now, what happens when you have 10 floors? Let's say we have 10 floor or 10-story building, and you are going to measure a slab. You are going to measure slab, and slab has different thicknesses. Sometimes you have 200 millimeter, 100 millimeter sunken slabs are there, upstands are there. So let's say you have about 3 or 4 thicknesses of a particular slab, right? So you have to create dimension groups. Let's say 200 millimeter thick slab, 250 millimeter thick slab. So likewise, you have to create dimension groups if you have to measure superstructure. Now, you have the same thicknesses maybe on the second floor. Third floor also we have the same thicknesses, or maybe slightly different thicknesses. Now, let's say in the first floor you have to create 5 dimension groups, right? And in the second one you have to create another 3 dimension groups, so altogether 8. And if you have about 35-story building, you will end up with creating about 40-50 dimension groups. So that will be a headache. So CostX has given you a method for that, something called zoning. So you can or in other words, CostX can record and store dimensions level wise. Dimensions level wise. Or zone wise. Let's say grid 1 to 4, grid 5 to 6, grid 6 to 10. You can measure that way also. And you can keep all the quantities related to grid 6 to 10 in one zone. Let's say zone 1. From 6 to 3, maybe zone 2. So likewise, you can zone vertically as well as horizontally, like ground floor, first floor, second floor, third floor, and so on. Right. So we are going to use that function, and also we are going to use we are going to measure one slab for the substructure. Okay. Right, now let's go to the BOQ. I'll show you the BOQ, the superstructure. You can see here. If you take the superstructure, you have all these BOQ items. So let us measure these what do you call thicknesses? Okay, let us measure these thicknesses as part of the superstructure measurement, but I will also explain the zoning. But before that, we will use we will measure one slab. So why they have introduced zoning is because otherwise we have to create the same dimension group for each and every level. So that will be a nightmare. Now, for example, 200 millimeter thick slab, first floor. 200 millimeter thick slab, second floor. 250 millimeter thick slab, third floor. So likewise, you have to create dimension group level wise. So that is not going to help. That's why they have introduced something called zoning. Right. Okay, let us create that zoning first. And also we'll copy this down to our CostX workbook. Okay, let's do that now. Go to the workbook again. Right, now we are here and go to the level 1. Now we are not here, superstructure. Now we are in concrete work. Right? As per the for me, we are in concrete work. Superstructure. So you double click and go to the BOQ level, and that is where you copy and paste your BOQ. So let us copy and paste this BOQ. So up to row number 338 from 317. Or you can use this one also. Heading also. Right, from row number 312 to row number 338. You just copy and paste it here. Not in the same page. We were in the substructure BOQ. And now that is done. You can see when you double click, you see the substructure BOQ level. And if you click on one of these columns, sorry, cell, you go to the measurement of that particular. Now you come back to the level 1. Now you are in concrete work. So you have to create a concrete work here. Can you do that? And this one here. You can copy the units also. Oh, sorry. Simply copy and paste, okay? Right. Now we are ready. So remember, we are in the level 2 now, but under concrete work, not under substructure. You double click this one and you get in here. Now what you need is you need to measure these thicknesses, this suspender slab. Right. So let us then, for that, you can't measure from here because there's no drawing. This is only the substructure drawing. So we need to upload a superstructure drawing now if you want to measure the superstructure slab. Right. And also we'll create something called zoning because now we have to measure the quantities zone-wise. Let's say first floors, ground floor to first floor is zone 1, right? So we create a zone because we want to keep our measurements separately from ground floor to the first floor. Therefore, we create something called zone. This is how you do that. Right. All the administration work you will find here under the file tab. Right. This is basically when you measure, you use this home tab, drawing tab, dimensions, of course, for the dimensions, and then revisioning we will learn later. And the workbook is the BOQ part, basically. So we have not gone into detail here, but this time we are going to go to some details. So you go to file, just follow me, right? Follow me, and then you have something called properties. You can see file, just go back. You see this file tab, and we have something called project properties. Okay, file, sorry, properties, not project properties, property. Project properties to define the scale and everything. Can you remember we discussed? Right. Here you have something called zoning. And this is called building properties menu. Building properties menu. Again, go to file. Here you have properties. And here you have zones. You can see here. And this is what we call as building properties menu. So if you want to introduce zones vertically or horizontally, in this case, we are going to introduce horizontally. All the quantities from ground floor to first floor will be stored in the zone 1. Right. So we are going to create a zone called zone 1 or maybe ground floor or whatever. Right. So building properties, and that is what you see. Can you remember base unit meters? So we change this to feet and millimeters, feet and inches. So this is it. Now in the same building properties menu, you have a tab called zones. And there you can insert a tab or introduce a zone. And again, when you click on this plus sign, you will get this kind of dialog box and zone name, let's say ground floor to first floor. So I have created a zone called ground floor to first. It's like you are creating a folder within your manual taking off. So all the quantities from, let's say, ground floor to first floor, you will store in that particular folder. Similarly, you are creating a folder within the CostX. Think that way. And you give a name, right? You can give a description if you want, right? Can give us our name, let's say up to level 1 or yeah, put this way. Right. Then nothing much to, you can see at zone from standard zones also. You can add from zone 1, new construction, blah, blah. You can do that one also, but otherwise you can create your own zones, saying ground floor to first floor, or should we say level 1? Level 1 is level ground floor to level 1. Let's say level 1. I think that will be much familiar. And say insert. Description. I'll put a small note saying that it is ground floor to first floor quantities. And say insert. Once you do that, you can see this has been created. Right? This has been created. Now, if you want, you can create another level, let's say level 2. That, or if you, let's say if you don't want this one, now you can delete this. Right? By mistake, let's say you have done a mistake and you want to delete it, you can delete it. Again, I will create a zone. How? This is your normal situation, and then you go to zones tab here, and then press the insert button, and then you give level 1, and description. Ground floor to first floor quantities. I'm going to store here and say insert, and I have created something called level 1 zone, right? And in same way, you can create level 2 if you want. Now you can see whenever I create, it gives you a kind of a folder structure. And if you don't like, or if you make a mistake, you can delete it. Not a problem. You can just delete it, right? Delete selected zone, delete all unused zones, right? And if you think this has to be moved up, level 1 has to be above, sorry, level 2 has to be about level 1, you can do that. You can select this one and say move up. You can see here, and then move down. So those things can be done. Insert, and then if you want to edit this, let's say you don't like level 2, you want to edit this, you just edit this, right? It could be level 3 or something, you can put it. So whatever the levels that you have created, there's a facility to delete, edit, and also there are facilities to include some new zones, right? So these are the working areas, and you are going to store your data within CostX in these folders. I mean, remember that way. This is not rocket science. They are going to create some folder structure within the CostX. Can you do that? How do you do that? Okay, I'll close this. File, properties. You have project properties also, not that one, project properties. And then you select something called zones. And then insert. Can we insert these two? Then I will show you application. Normally, when you do your quantities in as per the principle of measurement, for me, even you don't have to create these zones, but someone will like their quantities to be separated or segregated level wise. So you are going to give a combined figure, right? So for that purpose, this is very important. You can keep your measurements either grid level or grid wise or maybe level wise, both ways. Now in this case, we have selected level wise. Right, you can just move up and down and see how it works. That's all. And then edit. Right, if you want to delete it, delete and see. Right, so I have done this, fine. Just let me know everyone has done this. Can you drop a message when you have done it? Good. Right, so you have created the zones. I'm happy. And just delete, edit. And if you want to insert, you can just insert one and then delete. Right, so be familiarized with this. But this is called building properties dialog box. And in there, this is what you normally get. But then you have other two tabs. The last tab is not the last. Last tab is rate library. Uh, the before one is zones. There you can introduce your own zones vertically or horizontally, either way. You can have level, let's say zone 1 called grid number 1 to 6, right? Level 2 for zone 2, grid number 6 to 8. You can do that way also. Right, so once this is done, you just close this. Now you are ready. And now we are going to measure the superstructure slab thicknesses. We are going to measure these thicknesses. Okay. Right. For that, we need to upload a drawing and then calibrate. We all know basic now. Let us take which one? Let us take CAD drawing now. Call structure and then CAD. Which one? $202. Okay, let's get this one. And let's take a look on the PDF, then you will understand. Yeah, 202. Yeah, this one. You are going to upload this drawing and to measure the concrete quantity of this slab. And there are different thicknesses. I will show you. You can see there are different thicknesses here. This is 400 millimeter thick panel, 500 millimeter thick panel, and other areas different thickness 250. So there are different thicknesses of slab here, right? So you have to measure the thicknesses separately. I just wanted to show you how to measure the slab in the superstructure whenever you have different thicknesses. Right, so we are going to upload this drawing, but not PDF, AutoCAD. So I close this. And I'm going to upload AutoCAD drawing of AD5202. Okay. So can you upload along with me? How do you do that? Drawings, go to drawings and add drawing. You have to go to your folders. Go to drawings, structural, Muscat Hotel, and the Muscat structure, not PDF, AutoCAD 202. Open. We need the model. Yeah. And there you need to give a proper name. 202, I would say I'll leave the drawing number as it is, level 1 frame. Right, I'll give a name called level 1 frame. That means first floor level. Okay, first floor level, and I say okay. Base unit is millimeters. And we have to calibrate, we all know now. Right, done. Uploaded. You can see now I have actually, okay, I made a mistake here. This is not substructure. This is not substructure. So now you can change the file name. Here you can see file name. Now that is file name of the file path of this particular file. File name, sorry, folder structure is not substructure. I'm going to make it to superstructure. Right? Superstructure is one word, right? Super. Don't worry about the spelling. I'll say superstructure folder. Let's see whether it will allow me to update. Yeah, done. So I have uploaded the drawing and under a separate folder called superstructure because this was substructure and this is superstructure. So can you upload this drawing under a folder called superstructure, sorry. And you are going to measure this. And we have different slab thicknesses now. We are going to measure those. You can see here. There are different thicknesses. So it seems this is a flat slab. And if you interpret this one, it will look like this. Either this way or this way. So there, the slab thickness is different. Or sometimes some people can say it is a flat slab with column pedestals. So column pedestals can be measured separately, either way. Or you can measure this as a, let's say 600 millimeter thick slab, this portion, and the balance is 225 or 250 millimeter thick slab. So either way it is okay. Sometimes you can measure the entire slab and then the projected part at the bottom can be measured as pedestals, column pedestals. So people use both methods. I use thickness wise. I use thickness wise here because the BOQ given here is in line with that concept. There are different thicknesses and we have the quantities. I'm going to measure one by one now from this. Right. So you have you uploaded this one and let me know. Right. Now I'm going to measure. Now you can see the slab is 200 millimeter thick, entire slab, but there are areas with 400 millimeter thick, 500 millimeter thick, and 600 millimeter thick also, if I remember correct. I can't. Okay, maybe in the next floor. Right. So this is first floor. Right. You see 500 and 400 thicknesses. We can also include, or we can also now, this is 202, that is the level 1. We can also upload 203 drawing, same way. We can measure that level as well. So that also drawings, add drawings. And here you have next level, 203. And add, and we will say level 2 frame. Right, folder structure, superstructure. Or you can give it as superstructure concrete if you want, right? Superstructure concrete. Now you can see here superstructure concrete. Here also you can change now. Double click. Here you can change if you want superstructure concrete, same. Now you can see it is superstructure concrete. Right, so we have created a folder structure like superstructure and then concrete. Under that folder, I have stored level 1 and level 2 frame. Right, this is level 1 and this is level 2. You can see it. And in there, I can remember there was 600 millimeter thick panels also. Maybe here. Yeah, 600 millimeter thick panel. Now we are going to measure these two slabs thickness wise. Right. So how do you do that? What is the next procedure? Now we have uploaded the drawing. Fine. And then given the folder structure, name, all good. What is the next step? Anyone? If you want to measure from this drawing, what is the next step?
I have to calibrate it.
Exactly, you have to calibrate it. And also, if you want to measure 250 millimeter thick, that means you have to create a dimension group called 200 millimeter thick slab. And 500 millimeter thick slab if you want to measure 500 millimeter, 400 millimeter. So since we have to measure all these thicknesses according to the BOQ here, we have to create dimension groups according to these thicknesses. And then we have to work accordingly. So let us now, so since we have uploaded these two drawings, now let us create dimension group. Okay. How do we do that? Go to dimensions, add dimension group. Can you follow me? I hope you have added these two drawings already. Now we create a dimension group. How? Dimension, add dimension group. What do you want? 250 millimeter thick slab. Right, folder, where do you want? Concrete. This is the folder structure you are creating here, okay? Down. Now we don't want to put everything into the concrete folder, so because we can say concrete super. Concrete superstructure. You can have the same folder structure, both drawings and the dimension groups. There's no harm. Right. How do you measure? You want measurement type area, but default display in volume. Right. We'll talk about offset later. Default height is now, since we are measuring 2.25, you can say 0.25. Right. So default height is 0.25 meters. Offset, we'll leave it like that for the moment. And then insert. Now you can say we have created a dimension group called 200 millimeter thick slab to be measured in cubic meters. So can you do that quickly? And then we'll calibrate this. We'll start with level 1. And also I must show you something here. Can you remember we created a zone? Now you can see that is appeared here, zone category 1. You can see level 1, level 2. We have created and that is appeared here now. I'll tell you the importance of this one in a minute. But now, don't worry about the zoning thing. Since we have created a zone called file properties, and then this zone step, we have created a zone for future use. Once that is done, you have uploaded two superstructure drawings, frames, and you have also created a dimension group called 250 millimeter thick slab, and now you are ready to measure. But before that, you need to calibrate the drawing. So can you calibrate this? How do you calibrate now? Drawings, eh? And you can actually AutoCAD is very easy. Right? Calibrating AutoCAD is easy because it's almost 1-to-1. So calibrate x-axis 5100. Perfect. Say okay. Now you just measure and see. Measure distance. 2.225. Perfect. So that is done. And similarly, you can measure, you can calibrate this as well. Same thing. Calibrate x-axis and apply factor for y-axis. Yes. And this is 5100. Fine. Okay. And just double check one of this using measure distance. Perfect. 1.850. So that means this is properly calibrated. Can you do that? Everyone has done this? Uploaded these true drawings plus calibrated. Now we are ready because we have created the dimension group called 200. Now you can see the importance of this folder structure also. When you have so many dimension groups, let's say maybe sometimes 50, maybe 75 dimension groups, you will get confused, right? And also you can check, now you can see, uh, you can always do a filter also sometimes. If you, let's say if you have 100 items, you can quickly filter. So that facility also there. Okay. You can just click on this. You can just filter, let's say 250. You can see here. It's coming up. So that can be done whenever you have so much of You can filter and select, okay? So that is possible. What happened to that? Sorry. Just close and open. Yeah, we are here. And we are here to measure level 1. Right, now we are going to measure 250 millimeter thick slab here. Now, you know, there are so many unnecessary lines here. So I would assume this 250 millimeter thick line is the green line here, okay? I'm going to measure the area. But I know there are 500 millimeter, 400 millimeter thick panels. So I'm going to basically deduct those panels from my total area. That way you can get total 250 millimeter thick slabs. Because I have defined the thickness, I have to measure the area. Now let us do that. How do you do that? I'm going to measure, I'm going to plan now. That is where we use invert function, right? So you go to layers, correct? And then when you go to layers, your cursor color will change and you click on this edge, right? So that is your boundary, correct? And say invert. This is it. This is your 250 millimeter thick slab boundary. And this middle part is, of course, we know there was a staircase. Right, just double check. Yeah, there was a staircase. We are not going to measure that one for now. But there are some steps and then the landing, it seems. Right, we are going to measure only the 200 millimeter thick slab under this exercise. So again, when you go to layers, and then when you click on this green line, it disappears, and then you say you recall that one call by using invert. That is it. And you are going to now measure the area. Correct? Now you come back from the layers, sorry, drawings, right? And then go to dimension, and you are going to measure this one. Correct? You're going to get the area. Simple. But problem is you have some 400 millimeter thick, 500 millimeter thick area. So I think we have to see that as well. So let us go back now. Drawings, show all. We select those things also. So go to layers again. Follow me. You can also do along with me. Layers. And we select this line. Right? And plus this blue line. And probably this circle also. Otherwise, you don't know which one is which one. Thicknesses. It's difficult to select. Yeah. Okay. No issue. Go to invert. And now you have to see the labels. There are so many layers, difficult to find out. Ah, here we go. We got the identification. We know exactly which box has a thickness. Anyway, this is also 250. You don't have to worry about this one because when you measure the entire thing, this will also include it. So my focus is on the green line. And then you can deduct these areas. So I did not show you how to deduct so far. There's something called negative dimensions. So we'll apply this one now. We are going to measure. So I have created this view removing unnecessary lines and all the other data. Right? What did I do? I go to layers and then select green line and the blue line. And I was not able to select this what do you call labeling. So labeling I have used from here. So I have just made some trial and error. Then you found the labels. Okay. And then we are ready now to measure. Can you create this view first of all? We are going to measure the 250 millimeter thick slab. Right. So that is the view. And you are going to create the 200 millimeter thick slab. But remember now, since we have already introduced some zoning, now this slab belongs to which zone here? Now here you can see zone category. You have to select the zone category. If it is blank, we'll be in trouble. Now, because we have already created a folder called zone 1. So this is in zone 1. So you need to make sure that you have selected the correct zone before you start the measurements. Otherwise, these measurements will not be stored in level 1. Right? So when you measure the next level, you have to select the level 2 from here. So you have to be very careful in selecting these zone categories. Otherwise, your quantities will be stored very haphazardly. Right? I will show you the application when you prepare the BOQ for this. Right? For now, you have to select the zone category 1. You have to calibrate this and you have to remove unnecessary lines, which is this one, and you are ready to measure now. Now you are going to measure 200 millimeter thick slab because you are in the dimensions tab now. Now we are ready to measure. You can see negative, positive. I'll show you negative method thing. I'll take point or line. You must be asking why you don't use what do you call shift. I'll use shift. Now you see what happens. I press the shift because it's very difficult to match this. You can see very difficult to match the odd shapes because you can see some edges, tiny edges, recesses, and so on. So if you use the shift key and you don't find the proper area here, so that is not going to work now. Now, when you do this one, let's say when you want to deduct this one, it is very easy. You can see, you can select the area. But here, since you have small projections and so on, difficult to use that shift key. I'll go back to the basics, either point or line. Yeah, probably line. Right. So I'm going to measure. Okay. Right. Just clicking, that's all. We just click. Can you follow me? There are some tiny edges. Sometimes difficult to select. Again, I'll start. If you can't difficult to select, or if it is difficult to select, what is the best method is the line point mode. Okay, I'll use the point mode. So can you also follow me? It's like you are drawing a polyline, isn't it? In AutoCAD. And you just use the point mode to calculate the area. Finish. Enter. Here we go. You got the area, right? When you have these recesses and small projections, the best method would be point. And you can see 134 cubic meters, but we know it is not the case. We have taken the full volume, full area, and we have different thicknesses here. You can see 400, 400, blah blah blah. Now you have to deduct these areas from 250. This is one method. I'll do another method later, but this is a basic method. You get the area, and when you do it manually, you will also follow the same concept. You get the full area and then deduct other thicknesses, and you get 250. Right? So this 250, 134 is not correct. You need to deduct. You can see the breakdown here. You can see 134.21. Right. Now, what you need to do is you have to deduct. Okay. This is the first time you are going to deduct some quantity. This is called negative dimensions. This is called negative dimension. Normally, by default, what we are doing is positive dimensions, remember. That's why you get it in green. But if you want to make it negative dimension, you have to click this one before you start measuring. Otherwise, it will be added. Now I click negative, okay? I'll click negative and I'll deduct. Okay. You don't have to go this way now. What I can do is you can use the shift and click. Sorry. Again, enter. Correct? Now you can see what happens. 134 became 133. Now I'm on negative mode, okay? So I'm going to deduct all these things now. So I'll do it again. Control Z, undo. Right? I did undo now. My original was 134, that is positive. You can see. I'm going to do negative dimensions now. I'm going to deduct. So you can see it comes back to the normal view. Either you can use point mode or line mode, that's okay. Or you can use shift and mouse. Shift and mouse, enter. Or click. Sorry, click. Right, you can see it shows as a what do you call red. Right. So let us measure all these other thicknesses. Right, shift. As I said, when you move the cursor, it will match your deduction. And click, 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 click. Very easy. When you use the shift key, it is very easy. Shift, shift, shift. You move the cursor until you get your area covered. Right, done. Now all the negative areas I have measured. Now you can see what happens here. 130 something became 120 because you know that area is not part of the 120, sorry, 200 milli, 220, 250 millimeter thick slab. Correct? Now if you want to see both, now we can see how the positive dimension is green and negative dimensions are in red. And the red ones are the deducted ones later on. Right? When you see both, you can see both. If you want to see positive only, you can see positive. If you want to see negative only, you can see negative. If you want to see both, this is how it is. And if you go to dimensions now, you can see negative dimensions now. Negative dimensions. Remember here, when I apply, now I have created a dimension group called 250 millimeter thick. There I have given a default thickness or default height of 0.25 because that is the thickness of that slab. So when I introduce negative also, when I deduct this area, for example, thickness also will be taken as 250 because I want to deduct this area, but then multiply it by 0.25 automatically to give the volume. It's not like we have calculate the entire area first and then multiply it by another thickness. No, thickness is automatically multiplied internally. When we measure an area, so what we get is here volume including multiplying by 0.25. So when I deduct this area, that is also the same case. You can see here, volume is 1.25. Right, count 1, length 9, length is the perimeter, height is 0.25. You can see the thickness has been taken as 0.25. It's okay because we are going to deduct that amount, that area. Yeah, we know it is 0.5, but for the deduction, it's okay because area into 0.25, we are going to deduct. So deductions have come properly, accurately. And your area is 120 cubic meters here. And remember, we are in level 1, zone wise. Right, can you quickly measure this one and get this 120? you should be getting 120 cubic meters. Before the deduction, you should be getting 134 cubic meters. Can you drop a message? Can you do that? Okay, everyone is getting 120. Good. After the deductions, Alind, Siba, Tusit, good. There's no magic. I mean, simple area calculations. But you need to understand how it works. So since we have given the dimension group the default height as 0.25, whatever the deductions also will happen area into multiplied by 0.25. Remember that. Since we have given the default thickness of 0.25 in that particular dimension group. Deductions also will go in that way. Right. Now you see, if you want, right, you can see, go to drawings and 3D view. Don't forget, you can always check this out. Why it is only red then? Go to dimensions, right? Select both. Now we have earlier you selected only negative. That's why you see only the deductions here. Okay. Actually speaking, it is both. And you see the same thickness. Okay. Same thickness. If it is not 400 millimeter thick, if it is 400 millimeter thick, it is a different scenario. So it's like we have a 200 millimeter thick slab and we have cut out some openings so that your effective volume is 120 cubic meters. But you know, as per POMI, we normally deduct any cutout less than 1 cubic meters, right? So if in that case you don't, you do, I mean, if you have a cutout, not this kind of cutout, those are actual cutout because this is a different scenario because we have different thicknesses of panel. So for that we have deducted. So you can't apply that principle here. But if you have if you have kind of a genuine cutout, a shaft, which is less than 1 cubic meter of volume, then you don't have to deduct as negative. So you can follow measurement rules as it is. That's why you have to be a smart QS. Right? Just play with this and see how it will work. Right. Now, okay, we have measured 250 millimeter, and then we had two different other thicknesses also, right? So you go back to this. We have two other thicknesses as well. Right. So what you do now, we measure 400 and 500 millimeter thick from here. Right? We can measure 400 millimeter thick and 500 millimeter thick slabs. For that, you need to have another dimension group, two dimension groups. One is, okay, 250, we have done it. We have measured it, right? So in that case, we have used the negative dimensions to deduct those other thicknesses, and you get the value here. Now we are going to measure other thicknesses. How? We take a copy of this and make it as 400 now. Yeah, 400 millimeter thick slab. Do we need to copy dimensions? No. And we can keep it in the same folder structure and say 400. Fine. Done. But we didn't change the thickness, remember. We didn't change the thickness. Then you can make a huge mistake if you don't change the default height. Now it is 0.4. So that is the danger of taking a copy of the previous dimension book. If you don't change this one, you will be in trouble and you will make a mistake. You change this to 0.4 because we are going to measure 0.4 or 400 millimeter and update. Right. Now we are going to measure 400. Very easy. You can use this one. Now it is not negative dimension. Now it is your positive dimension because you are going to measure 400. Right. So go to dimension. You don't have to say positive, right? And by default, you are anyway measuring positive, right? So let us measure positive 400. We are in the 400. Use shift key now. 1, 2, 3, 4. That's all. Right. We get 8 cubic meters. Right. We get 8 cubic meters for 400. And let's measure 500 also quickly. I need you to follow me. And then you'll take a copy and make it as 500. But that is not enough. Right. We create this one and immediately come back and change the thickness to 500. Everything else is correct because you are going to measure area. Your output should be in volume. All good. And so you apply. Now you measure 500. Keep 500 here. Shift. Okay, good. So did we measure everything? You can double check. How? Yeah, we measure everything because we have selected the both. Then it should reflect here. So we have selected both. And if you need color changes, you can do that. Here, you can just double click and you can change the color here. Right. And then you can identify 400 and 500 separately. But you can see we have selected level 1. Here also we have selected level 1. Fine. Good. Right. We can do the same thing for the other flow also. Now we have measured. Now the problem is, as I explained you earlier, now we know in both levels we have 250 millimeter thick slab in both levels. Now if you go to this one, you see it's 250 millimeter thick slab. Right? This is 200 millimeter thick. But I did not create separate dimension group like 250 millimeter thick slab for first floor, 250 millimeter thick slab for let's say second floor, then it will be a nightmare. So to avoid that kind of, let's say you have 35 stories and you have so many thicknesses and you have to create so many dimension groups, which is not practical. To avoid that situation, they have introduced something called zoning. So instead of creating so many dimension groups, what we do is basically we select the appropriate level. So we can use the same 250 millimeter thick slab, but we change the level 2 now. When we measure the next one. So by doing so, we can segregate the quantities within CostX level wise. I will show you how to do that. For now, right, I will stop in like 5 to 10 minutes. So let us measure the second one also. Again, you have 200 millimeter thick. So let us measure the level 2 now into different thicknesses. Okay. In the same way. Okay, first of all, have you got these numbers 128, 18? First, drop me a message. This is 128 and 18. 400 millimeter thick should be 8. Are you guys are getting the same value? 8 and 18. Good. Right, then can you follow me for the other flow? I hope you have used, if you don't have, let's say if you have not used level 1 here as zoning, when you measure this quantity, you will have to redo it. I'll tell you why. Not now, right before the next session. Before you measure these quantities, you have to select this level 1. Now, when you measure the second level or level 2 frame plan, you have to select level 2. Then only these quantities will be stored under separate folder. These quantities will be stored under separate folder. Right, so we are going to use the layers here and use the same thing like previously. And then we'll say blue line also and the labels. Labels we have used somewhere. Okay, then we do the invert function. We have to use internal line now this time. This is the parapet it seems, okay? But still, okay, if you have a parapet, the edge is here, correct? And then the label I did with it. Yeah. Still, this labeling is different. So that is 500 for some reason. It is 500. And this one also. Let's go to show all again. And you have 600 here also, right? Again, we'll do that. Let's assume this outer edge is the line. And then you select blue lines. Only thing is the label. Probably this one would be better. Yeah, partly difficult. That's a difficult one to get rid of the lines because the drawing has not been done properly. But still, let's say outer edge is what you want. Only thing is labeling. We got some. Probably we can manage with that. This is 500, I think. This we can find out which one. We'll live with this, okay? And I'll use the outer edge. Right, so I'm going to measure again 200 millimeter thick, but in a different zone. Because 120 is on the first floor. Now we are going to measure the second floor, level 2. That's why I have selected the zone as level 2, and I'm going to measure now. Right. I used point mode. Right. Done. Now you can see what happens. It became 247. It became 247. Now we'll apply negative dimensions because we don't want these areas, other area. So let us use negative dimensions now. We can use shift key for that. Yeah, that's it. Both. So it becomes the 236. Now let's see. We have captured all. Here we have 400. No? Anyway, those are mechanical pads. I'm not going to use it. Yeah, that's enough. Right. So after deducting both the quantity in both slabs is given as 236 for the 250 millimeter thick. So are you getting this 236? So don't take these are mechanical pads. So similarly, now you can measure 400 millimeter thick slab in level 2, 500 millimeter thick in level 2, and 600 millimeter. That we have to create another dimension group for 600, but let us measure now 400 also, right? 400, you don't have to do anything. You can just measure this way also. Now we are in 400 and make sure that you are in level 2, right? You just, these are 500, these are 400. You just measure, sorry, because this drawing is not drawn properly. Layers, that's why it's very difficult to differentiate the lines. That is 400, this is 400. Yeah, that's it. It became 16 cubic meter. This is without pedestals. And you can do the 500 also. So keep your cursor on the 500 and measure 500. We are using the previous dimension group. That is the difference here. We are using the previous dimension group without thinking about the levels. Levels we are selecting from the zoning. Right, 500. That's all. We can double check and see. We have measured everything. Yeah, other than this panel, that is 600. So this is pretty much okay. You should get 528 cubic meters altogether. And then see 600 millimeter. We'll take a copy of this and we'll make it as 600. Same folder structure. Okay, but we have to change this one to 600. Yeah. And with that, we'll measure 600 here. From the 3 cubic meters. Now you can see both the quantities. Right, level 1 level quantities are segregated here as 236. 400 millimeter slabs on both levels, 16. 500 in both level, 28. 600 both levels, 3 cubic meters. Now, how do you get the breakdown? I will show you next week how to get the breakdown. If you want, you can do this way. You can select this one and go to dimensions. Now you can see it doesn't show you the zoning as such, but it will show you uh, the breakdown. That's all. Okay, 236 breakdown is here. Now we have to prepare a BOQ. When you prepare the BOQ, we certainly know that we have to drag and drop these quantities. And that is when it will recall zoning. So I'll prepare a so next time we'll prepare the BOQ for this part. Then you will understand how this zoning will work. Now we all know that we have created zones. Effectively, it is a folder structure within CostX, right? And that the measurements that we have done are stored level wise. That means in a two different folders. So we can use these two different folders um, in preparing the BOQ. So I'll show you that one. But make sure you get these values. This is for the both labs. So drop me a message if you are getting this one, then we'll stop here. And next week I'll prepare the BOQ for this part, then you will understand how the zoning will work. Now put me a small value. Right, are you getting the same quantity? Siva is getting 236 cubic meters. Slight, maybe some minor error. You can double check. Okay, all the others are getting it good. It has to be 236, 16, 28, and 3. Right, there could be minor errors that could happen when you select the edges, right? When you measure the 250 millimeter thick, if you are doing it very carefully, you will get the same value, 236. Okay, are we okay now? We are going into different concepts now, slowly. Now we know how to prepare a BOQ from the dimension groups. Now we will expand on that, right, by measuring superstructure. Now we have just measured superstructure slabs, different thicknesses, and then we have learned something about negative dimensions. What do you mean by negative dimensions? That is a deduction that you need to do, right? And how to apply negative dimensions we have just learned. And now we have learned something called zoning. And then we'll prepare the BOQ. During the preparation of the BOQ, I will show you how the zoning will work, how to segregate quantities, how to record the quantities zone-wise within the BOQ itself. All right, do you have any questions before I call it a day? All good? So Siva, double check whether this is you are getting 236 or 235. There could be minor error somewhere. So when you select the line, sometimes you may have selected some other line, the edge basically. Or you have not used, you have to zoom in and, select certain kind of accurate edges. That could be another reason. Right, all good? So I'll stop here then. When we meet next time, we'll prepare the BOQ for the superstructure as well. Concrete part, okay? Yeah, good. Right, so I'll stop here and thank you very much and good night to all of you. Take care. I'll see you next week. Thank you.
Thank you, sir. Good night.
Good night. Siva, you need to double check your quantities, right? Make a note of these quantities and these are the correct quantities. Without this mechanical pads. Okay, sometimes you may have used these mechanical pads. So watch the video and see you have also selected the same area as mine. It's a minor mismatch. Okay, good. Good night. Thank you.